Now we're going to solve this question using M&A and the HP50G, which is what many of you, my students, did. Let's see. We begin, of course, removing this impedance here, 3 minus J3, which is to be taken out according to the description of the problem. And now we have identified nodes 1 and 2. We choose the branch currents, as you see, or any other way you want, just be consistent, and write 1 and 2 KCL equations. After all, there is no control source here, there is no op-amp, and there is not any single branch with a single V source. 2 KCL equations. I prefer to use letters instead of writing those complex numbers in polar form. To simplify my notation, I'm going to call them X and Y, like so. And we can write the 2 KCL equations this way. This current on the left arriving in node 1 is X minus V1 divided by 2, 2. X minus V1 divided by 2, 2. And that is equal to these two currents. V1 minus V2 divided by 2, negative 2. V1 minus V2 divided by 2, negative 2. Plus the one on the top, which is V1 minus V2 minus 50, which is 5, divided by 2 ohms. V1 minus V2 minus 5 divided by 2 ohms. By the way, for the second equation, KCl2, those two same currents will be arriving in O2 there on the left-hand side. So I just will copy these ones from the first equation and paste them here in KCl2 plus Y equals to the current here, which is V2 over 2. Those are the two equations we solve for V1, and that is the value we need to report. And you're saying, well, sure, show us how you're going to find that. And you know I will be using HP50G, which is what many of you did. And many of you did not type them actually on paper because nobody was going to see that paper procedure anyway. It's not the final exam after all. So you write them directly in the calculator, which is what we are about to do. So we type currents arriving in node 1, which is X minus V1 over 2, 2. That is equal to the two currents leaving. V1 minus V2 divided by 2, negative 2, plus the current on the top branch, which is V1 minus V2 minus 5, right, was a real number divided by 2. I select all of those to copy and later paste them in the second equation in KCl2. That saves me a lot of typing, a lot of mistakes. That is, I have pasted that plus Y, and all of that is equal to the one current leaving, which is V2 over 2. Two equations, make them into a vector. What are the unknowns? V1, V2, two of them makes me an array, and we are ready almost. Let's check whether the flags are in the right way. But before that, let me create Y and X. You see 10 with 30 degrees, 7 with 30 degrees. I stored the second one in variable Y, the first one in variable X with store. X and Y, you see them there. And now check that the flags are zeroed. And we are ready for the symbolic solver and for the linear solutions, right? Symbolic solver, linear solutions. There you go. However, we don't care for all of that. Objects in two pieces, delete V2, and evaluate V1. V1 has been evaluated by the calculator because it already has the value of X and Y, and those were the values you needed to report. Magnitude or absolute value of V1 13.4 and angle 31.7 degrees. Thank you very much.